Hello.
Hello, do you know about science?
No!
Okay, this phone is going to blow up.
Got my note cards. As the ball falls, it is in motion. The ball is moving and slowly getting closer to the ground until it hits. As the ball is falling, it gains momentum. What else is being used right now? Gravity. Gravity makes the ball fall, and it decides the force to apply to the ball as it pushes it down towards Earth. Friction. Friction might not be very present here, but it is still slightly there due to air friction. As the ball drops closer and closer to the ground, it is pressing against the air, and it will create some resistance for the ball. The ball uses energy, kinetic, potential, and thermal, all in the process of bouncing and dribbling. The ball, when it rolls, it slides on the ground. As you can see, there's friction because the ball is rolling against the ground here. And no, you're not usually going to roll a basketball in the middle of a game, but if it were to roll, there would be friction. Back at you with more science information. I got my handy dandy note cards again, and we're gonna be moving on with some more words. Force, as I already explained. Gravity can decide the force to apply the ball and push it downwards with a downwards force. Contact force. When I purposely push the ball down, I am applying force to the ball. If I were to drop it, that would be on gravity. But if I am to push it towards the ground, that is me. Mass. The ball has a certain amount of mass, which can also decide the speed that it falls at, and the shape can also interfere with pressure, like air, if it gets caught in the wind. The ball falls, and the mass decides how quickly it will reach the ground. If it was much heavier, it would fall much quicker. Acceleration. If the ball is to start up, it drops and slowly gains speed, or accelerates. The speed is how quickly it falls. Velocity. Applying force to the ball can give it a good amount of velocity. If you throw it, or bounce it, or dribble it, you're applying speed and velocity to the ball. Ready?
Small things. Basketball.
Fluid. As the ball falls, the air is fluid around it.
N for Nicholas. And S for science. So cool.
Static. The ball is on the ground right now. If we wait for it to stop moving, it's just sitting there. If I am to push it, it's static. If I, action and reaction, if I am to act upon the ball, push it towards the ground, it will have a reaction of bouncing back up towards my hand, or really just up.
Basketball shows a lot of scientific things underneath the actual game. When this ball is just sitting on the floor at rest, it will stay at rest until another object acts upon it and moves it. And then it will stay in motion until another object stops it. That is Newton's first law, which is also inertia. So as I know, the mass of a basketball is 0.625 kilograms. And the second law is F equals ma, which is force equals mass times acceleration. So the more acceleration the ball has, it multiplies by the mass and it equals the force. So when I shoot the ball or even pass it, the more power I put into it, the farther and the faster it will go. Newton's third law of motion. For every action, there is an equal and opposite reaction. In basketball, when you dribble a ball, you apply force and you are pushing it down. So that means there will be an equal and opposite reaction of the ball pushing back off the ground and coming back up to your hand. Energy. There are three types of energy, just like Nicholas said earlier: potential, kinetic, and thermal. The basketball starts with potential energy, and as it drops, it converts into kinetic energy. When the ball bounces back up, the kinetic energy turns back into potential energy. When the ball hits the floor, there is friction between the ball and the floor, and that creates thermal energy.
We just taught you about a bunch of sciencey things today, and we used lots of words and vocabulary to help do it. This was a great video, and we had a great time.
Ow!